Oh, okay. Let's see. Can everybody hear me? Am I coming through clear? Let's see. Okay, just double checking, make sure I've got everything sorted out and available here. Yep, all good. Cool. All right, I'll go ahead and share my screen here, and we're gonna just dive right into things. So I am Jay Silvis. I've been doing this series of a sort of lunch and learn session every week for the last 2 months now, actually. And that started out with Magenta real-time music generation libraries. I tend to be focused on learning some sort of AI or machine learning based tooling lately. Here, I will give you an idea of what we've been doing up to this point. The whole intent for these sessions is just generally to be a learning platform for myself, for others who want to jump into this. But basically, every week I've been doing some form of. Oh, that's weird. Oh, I see what's happening here. There we go. So basically, every week I've been doing some sort of focused topic that started out with specifically the Magenta real-time libraries, which use a audio codec and then a text style embeddings. So you're matching words to different types of music content, and then Depth-former, a generative transformer that was used to generate music off of those embeddings based on the descriptive text that you would input. You could also, with these models, they were released by DeepMind a few months ago now. You could also add MIDI inputs and do sort of a sparse matrix sort of relationship between the different sets of prompts that you gave it. So you could give it multiple prompts and change how close or emphasized of how heavily weighted each one of those was, and sort of create some interesting combinations through that process. Yeah, so I did a couple weeks that were focused on that. And now, for the last few weeks, I have been focused on LLM architecture, specifically the book by Sebastian Rauschka, Build an LLM from Scratch. It's super informative. It goes very in depth into the process, the architecture, the data preparation, how you actually put together and build an attention mechanism, and how you can focus using different sets of sort of windows over sets of tokens to focus on individual tokens or the relative relationships in the embeddings, the sort of relative and absolute embeddings between different tokens. And then moving into building an attention mechanism, which is how the model actually knows what aspects of the input data to focus on. And then, so these have been sections we've kind of gone over the last few weeks. We are now, let me get my book caught up to this. Last week, we started going into the chapter 4 and 5 area, which is basically implementing a GPT model from scratch to generate text. Chapter 4, which I actually posted a notebook. I've been basically taking the notebooks, the content from this book by Sebastian Rauschka that was published back in 2024. And I've been taking a lot of that material and basically forming it into some learning notebooks, IPython notebooks that you could run on your device. But specifically that will work using the M series Apple architecture. I'm running on a Mac M4 with about 64 gigs of unified memory. So that gives you some abilities to run LLMs locally. If you have, you know, even just 16 gigs at this point, there are a lot of options. And I think you could still do a lot of the content that's in this book with that amount of unified memory. Even just RAM and a dedicated GPU on a PC would work from this perspective. But basically, chapter 4, after going through the text token data preparation, the embeddings process, then we start getting into the actual, and the attention mechanism. Chapter 4, we start getting into actually building out the LLM itself. And by the end of that, let's see if I actually had, yeah, I have this diagram here that I put together a few weeks back. So just to focus on that for a moment. So basically, we've been in this stage 1 area for a while now, which is entirely focused on just understanding and implementing the LLM architecture for training, being able to, like, knowing how to prep training data and sampling the attention mechanism, the architecture. But now in chapter 4 and 5, we're moving into this foundation model. So actually taking what we have built and applying it to some data and taking it through training loops. We'll start getting into the model evaluation and load pre-trained weights. So this isn't getting to like fine tuning yet, where most LLMs that you would use in various products are these days, like ChatGPT. We can set aside the point that it is actually part of a whole agent harness system at this point that has access to tools and can read in PDFs and browse the internet and do web search and dispatch sub agents to go and accomplish different tasks, even control your computer. All of that stuff is done via different sort of application programming later, MCP, and an access to a bunch of different skills and tools, all things that are part of the sort of context management that makes up the agent harness. But even before all of that, just the foundation LLM can be fine-tuned for a certain use case. In the case of ChatGPT or Claude, it's being fine-tuned after the foundation model has actually been trained, so that it specifically has a sort of personality of a chat assistant, something that is trying to be helpful and actually answer your questions. Whereas before you get to that fine-tuning process, when we're just talking about the training loop, the evaluation, and model pre-training or loading pre-trained weights, that is just building a foundational language model that can take some sort of input at inference time. So you can feed it text and it will just try to do the next token prediction of what's actually going on, or what is most probable after that text as follow on. And it can generate, but it's not particularly curated to any certain use case. It's just a general text generation machine. So that's kind of where we're at right now in stage 2. Chapter 4, I put together a notebook for this. So I think I published this or posted this last week. But basically, this is implementing the core GPT model. But when you get to the end of this, let's see if I can have this run real time. Yeah. So basically, if you are able to pull this notebook and you can run it locally, again, this is chapter 4, implementing a GPT model. It will take you through the process, along with some particular deep dive resources. There's interesting stuff like the ResNet paper. Oh, okay, there we go. So throughout these notebooks, I've weaved in some additional resources that are super interesting to dig into if you want a little bit more than what the notebook itself kind of takes you through. These notebooks are very much focused on just straight practical application. Take the ideas from the book, take the ideas that Sebastian Rauschka did in the original 2024 implementations and basically set this up specifically for running on a Mac locally, and demonstrate the process that way. But I've also added in some resources and research papers where relevant, to expand upon that material and add some background context. So you will find those sort of inserted throughout. There's also exercises. So for instance, extending the demo to 10 layers. We started out here and it's a 12 layer stack. Or sorry, barely trained GPT-3s, 96 layers wouldn't train at all. Yeah, so we're working with very small amounts of layers in these implementations because it's running on your local laptop. We're memory constrained. If we had a stack of H100s to run this on, then we could build a more capable model, but these are all small, just implementation examples. So yeah, this one definitely worth digging into further now as we're fully in this sort of implementation section. You can even see this total parameter count here. We're talking 163 million, which is still, if you think about it, is impressive that we can even do this on a laptop these days. So yeah, so some of the M4 Mac adaptations are outlined here at the bottom. This obviously may not be relevant to your specific laptop. What I would suggest is you just take these notebooks and basically look through them, figure out where it's diverging or where you need to change the compatibility to whatever device you're working on, and then work with your tool of choice, your AI assistant, Claude, Pi, whatever it is, and basically just have it focus on the specific areas where this needs to be adjusted to work on the hardware that you are running on. And that could even be cloud resources, but this is just a sort of implementation example. So I also have chapter 5. Let's go back up to the top here. So this is that pre-training on unlabeled data. So this section goes through a couple different areas. First, just measuring the actual text quality. So this touches on things like cross entropy, loss, and perplexity. It also goes through the actual training process of the GPT, or the training loop, what we were just talking about here in this diagram around what comprises the foundation model. Then we also have just the actual how do we make generation, like the actual output text that is generated at inference time, less robotic. And an important distinction here that I think maybe is always good to touch on. Whenever you're talking about running training and using LLMs, there are two major phases. One is the actual training process, which comprises all of what we've been prepping information for, data and the architecture and attention mechanisms, the embeddings, all of that is sort of feeding into this training loop process once it's all put together. And that is a very different task from a computational perspective than the actual inference time compute that a model that has already been trained. We now have a model with a static snapshot of weights that have been trained, maybe fine-tuned for a particular purpose, like a chatbot or a classifier. And now that we have that static snapshot, that model, what you do is you give it text, and its whole purpose at that point is just to process that, propagate it through the network, and try to resolve to the most probable next set of tokens. And that is inference time. That's inference compute. And so inference runs fairly well on local hardware. I have a friend or on this laptop, for instance, I can run models that have 30 billion parameters on this MacBook with 64 gigs of RAM, which is insane because in some capacity it's a distillation of countless texts and content and information and in from the internet. And in the case of these sort of more multimodal unified models like the Gemma 12B series that came out a month or so ago, those models actually have more than just text. They also have embeddings that are based on image data and even audio and video. So you're dealing with this sort of vector representation of just an unimaginable, from a human perspective, just an overwhelming amount of information, of content, of videos, of images and sound that has all been compressed into this numeric representation in a machine learning model. And so it is then able to process all of that. But the fact that you can even run a 12 billion parameter model on your laptop now, and even like a 1 billion or some of these quantized smaller versions of the larger ones on a phone is just insane, because it's like you've compressed the internet in a way into this textual representation. Anyways, nerding rant about just why this stuff is so fascinating to me personally, and why I want to learn more about how all of this works. So continuing forward, we were just summarizing the general roadmap for this notebook. So it covers some ways to make the generation less robotic. Some of that has to do with temperature and top K. Temperature, for instance, my understanding so far is just if you say you want to do code generation, you want the model's outputs to be optimized for code generation. Your expectation is that it's going to give you a very structured and consistently formatted text based on your response. Maybe you give it a text file that has a bunch of code, or say it's a .py, a Python file that has a bunch of code, and you're saying, here's what I've got, this is what I put together, it's not working. Like, help me find the bug. Or you would simplify this even further, because we're missing some of the harness features that would actually enable that. Let's say I just give it the name of a function and then open brackets, an open bracket, and that's it. Maybe I even say I want to give it even more context. I write the name of a function and I give it a doc string. And so the doc string is describing what this function should do, the expectation. And then it feasibly, this model will not be able to do this consistently because we're talking like GPT-2 level. But with more modern LLMs, even without the harness, you could feasibly give it the beginning of that function, and then it would likely be able to produce the rest of the text that is most probable based on the initial part of that function that you gave it. And it could, do the autofill or autocomplete essentially, and just predict exactly what that function would look like and return you a fully functioning function some of the time. So that is for that. So we're talking about temperature. In that case, you would want very low temperature, meaning you want the model to be less creative. You want it to be very consistent towards what you initially gave it, and not try to fabricate something crazy or less probable. Whereas if you're writing an essay or you're brainstorming, say you give it an initial prompt that is open-ended and saying, I'm trying to think through ideas for a dinner party where I'm inviting a bunch of friends over, and I know that I want there to be costumes and some crazy different kinds of food, and it's going to be themed like Game of Thrones. And it's going to be like a murder mystery dinner. I don't know. This is all just off the top of my head. I need ideas. And like that's your prompt, basically. For that sort of situation, you want a very low temperature. I think you actually want to increase the temperature. Well, correct me here in a second. Because you want it to be more creative. Basically, you want it to rely less on the most likely normal thing, the most probabilistic response or continuation of that thought. And you want to essentially reach further out into the vector space, away from the sort of nearest relative words, the nearest relative tokens, and get way out into the latent space of these model embeddings and find things that are more interesting or less expected. Then we also cover in this, how do we save or resume work, basically model check or training checkpoints, so that without that, you would have to run the entire training cycle at once. But say you're on a small device, you start trying to build a larger model, and you just are going to rely on the amount of time. It may take multiple days for a training run to actually complete. So depending on how many cycles you're going through and how long each training epoch actually takes, you need a way to pause and say, okay, we'll save the training progress, the adjusted weights at this point, and then pick it up at some later point. And then how do we skip the the money part? So loading OpenAI's GPT-4 weights. We're going to basically, this notebook focuses on using a very short story that has, I think, 5,000 tokens or something. Very small, not nearly enough to train a highly useful model just yet, but that keeps the size of the data that we're working with small, so that you don't need like a 40 gigabyte or 60 or more data set download just for this. Anyways, like I was saying, we actually go into like evaluating these generative models. And then, as you'll notice as you're going through this, there's also an exercise at each section. So like a sanity check, just to see how well you're actually understanding these things. This is a super useful link as well. So when you're actually training the model, Andrej Karpathy, of course, a lot of people in this domain have heard the name before. He put together a useful resource. This is just a YouTube link. I won't share the sound for that right now, but he actually has a video here where he goes through building an LLM or a GPT from scratch. So this is actually a super useful exercise to go through as well. Just some supplementary content as you might be taking the time to go through this notebook and the book and implementing some of these. So here you can actually see that we have started going through training epochs that are stepping through. And you can see the loss is adjusting downward as we go. And then afterward, we actually plot the losses, or the training loss versus validation. So training loss keeps falling while validation loss flattens or rises after a couple of epochs. So this is equivalent to the model memorizing the text data that we gave it, the story, the verdict. But as you can guess, just reading one short story does not give you mastery of the entirety of the English language or any language. So that doesn't necessarily help it to generalize well. It's still a very limited data set. So if we wanted to improve this, we would just need more text data. So this is another good point to maybe go through and poke some of the parameters that were actually defined here and see how things change. You can, do a series of basically retrain that, because that only takes, let's see, that only took 16.6 seconds to do that training run. So this is small enough that you can go back and you can try poking at different parameters, changing things, changing the number of epochs, starting with a different seed, messing with weight decay, all these different things. You can play with these different parameters and see how it actually changes your results. Yeah, we get into some things like decoding strategies. Let's see. So you can see how often these different tokens actually emerge in the toy 9 token vocabulary. Right. So what comes after every effort moves you, and it's basically seeing how often these other words pop up, which is interesting that pizza is one that even shows up in these training cycles. And then finally, saving and loading model weights. We talked about checkout or saved checkpoints. So that's model state.dict, so the learned weights, and then the optimizer state. And then loading pre-trained weights from OpenAI. So this is interesting. So our GPT model is the GPT-4 architecture. So instead of spending 100,000 of compute to pre-train on web text, OpenAI's 40 gigabyte scrape, we can pour their released weights into our own class, and our from scratch code suddenly speaks fluent English. This is interesting. I mean, you're basically piggybacking off of a lot of the compute and curated data, and then thousands of dollars of training cycles that were done on a different architecture. So it looks like originally it was TensorFlow checkpoints from the book, but instead here we're using safe tensors from Hugging Face. And we also have a resource here that is just talking about large language models. Large language models are unsupervised learning or multitask learners. Let's see, when was this actually published? This was, I don't know where there was a date for when this paper actually came out. Let's see, because I'm actually not seeing it here on the page. Published by OpenAI in 2019. Yeah, so that would be the GPT-4 architecture paper. Oh, we have a bug here. I will double check into that. Oh. So basically, I published the first version of this. I think I actually have an issue going on here, which I will circle back and address. But basically, I've done a cursory pass through this stuff. I usually end up going through these notebooks a few times over the course of the week. Here, let me switch back over to our overview process now, because I think we're at a good sort of pausing point. So I end up going through each of these sections in the book and the papers multiple times over the course of each of these weeks. The papers or the notebooks, I basically do a scaffold first with Claude, and then I go through and I may tweak some of these different sections and review different areas and do some of the exercises. So it's basically a supplemental learning process with the actual book itself. Your mileage may vary, or how you end up learning best. I think what's going to follow, because we're actually getting to the point now where we can start training these models and applying them to some problems, is to actually come up with some interesting examples, like maybe beyond what the book actually has. I think it goes over a classifier and an assistant, but I think it would be interesting to try out some other examples that aren't necessarily in the book. And so I'll probably go over some of those in the weeks to come. Anyway, so that is how far I've gotten this week. Just to give some general updates, I do have a baby coming up here very soon. So I will probably take the next week or so off, and just pause while we adjust to the rhythm there. I'm also paused on work generally for the time being because of that. Got to take some leave or paternal leave for handling the little one. But basically, I will schedule some of these out maybe for next month, and I think it's probably a good opportunity if you do find these videos after the fact. I've been releasing all of these over the course of July. Go through the material, find a PDF copy of the book, or buy a physical one if you prefer that, and like run back through the book, maybe read through it once, go through these notebooks. And then where we're at now is basically, all right, this whole sort of fine-tuning section now is actually like, what can you train your own GPT for locally, a small sort of GPT-sized model, GPT-2 sized model, and actually apply it to. And especially with the capabilities that we have these days, 2026, going into August, halfway through the year, what kind, like there's a scale of data preparation and fine-tuning process, and even using things like the sort of self-research agent formula, or an agent loop that Andrej Karpathy was messing with earlier this year, where you basically take an agent or some sort of agent like Claude or your own local one running on Pi or whatever, and point it at this LLM that you've been training, and basically have it try to optimize and fine-tune or do hyperparameter tuning, and try to minimize the loss. Or you can set that up to iterate on a particular problem that you want to see if you can actually make some progress on, and like have it go overnight and then check back in the morning, and think of yourself as a sort of research lead working with some assistants who can follow along a thread or an intuition that you perhaps have on how this model might be used, or a problem that it could solve, or maybe an adjustment to the architecture, or a different set of training data that you want to ingest and run the embeddings for and run training. There's all kinds of different dials to turn in that process. So as I'm learning through it as well, hopefully if you manage to go through some of this, you can find some of your own use cases where you might apply these things. Anyway, that is basically it for today. I'm going to go and check on this bug that I just found in the notebook for chapter 5, and then I will be posting that into the GitHub repo. So if you're watching this after the fact, you should be able to find it there along with any of those resources linked inside the stream. Oh, anyway, I will catch you all on the flip side in a future iteration of this, probably picking back up maybe mid to late August. I'm going to take a couple weeks off for the kiddo. So anyway, if you have managed to jump in and follow along with any of these, thanks. And if you have any thoughts on what would be interesting to focus on next, I would love to hear what you might be interested in learning more on. There's a lot of different topics that I really want to dig into. There's a follow-on book to this that a friend of mine is actually going to be going through and doing a book series on, or a book club on in the weeks to come for next month. And that is the Build a Reasoning Model from Scratch. That's the next book actually by Sebastian Rauschka. And that's kind of a follow-on to this one as a sequel. So that could be an interesting one to dig into, maybe maybe starting in August if I have energy. We'll see. If not, maybe that gets bumped over to September, where I do like a deeper dive into that book following that book club. Other things that I would really love to dig into, things I'm really generally interested in physical AI, so applications of computer vision and RL, or reinforcement learning. There were some different training libraries that I was messing with earlier in the year, like Mujoko, where you can train a simulated robot, basically a model that has articulated joints, and parameters that control the different servos and motors that control those different limbs and joints. And you basically train a model to be able to learn how to do a very specific movement. And then you build out whole routines or curriculums on that will go through an entire series of different actions. Believe it or not, the activity just of walking upright as a bipedal human involves many different micro muscle motor processes to actually maintain balance and stay upright. So training a simulated robot to be able to do that is one process. I'm interested in drones in general, and not just flying kinds, like general, like land, so marine, land, and air-powered drones. So just navigation and sensing, pulling together a lot of different kinds of sensors to build out a sort of sensory harness for maybe an agent-based system that is able to process what's going on and has like the base level sensor array and real-time data that's coming in constantly, and the control mechanisms that would be more of an RL problem to actually control movement of that robotic body, but having some sort of agentic layer on top of that. There's a lot of different subtopics within some of these problems that I'm interested in exploring further. So I think I'll be looking for books and material and specific projects that can explore subsets of that. And you know what? Maybe I'll even do a little bit of exploration into work in Unity, because I've also got a project going on right now where I'm building out some audio systems, some interactive audio systems for a Unity game on another team. So yeah, there's lots of different things where those different tools and skill sets cross over. So I think I'll try to weave in some of those in the future. But I would love to know what kinds of things that you might be interested in learning or having weekly topics focused on in the future. So drop a line in the comments, DM me on LinkedIn, or wherever you can. Yeah. Anyways, I will see you all next time.